Hello guys, welcome back to my YouTube channel. So today we are going to solve day 6 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today we are going to solve problem number 1813, sentence similarity 3. Okay, so let's read the problem statement first. You are given two strings, sentence 1 and sentence 2. Okay, each representing a sentence composed of words. A sentence is a list of words that are separated by a single space with no leading or trailing spaces. Okay, so see this example number S1. Okay, see S1 here. So hello and Jane. Okay, both the words are separated by a space. Okay, but in the starting and in the ending there is no space, right? Each word consists of only uppercase and lowercase English characters. Okay, two sentences S1 and S2 are considered similar if it is possible to insert an arbitrary sentence inside one of these sentences such that the two sentences become equal. Okay, note that the inserted sentence must be separated from existing words by spaces. So this is important line. Okay, so you guys will get better understanding with these two examples here. Okay, hello Jane. Hello, my name is Jane. Okay, sentence 2 and sentence 1. Okay, so this is extra portion, right? This is extra portion. So both the sentences can be made equal by inserting my name is between hello and Jane in S1. Okay, so hello and Jane, we are inserting this sentence my name is, and see there, here this is space, right? It is space here. Okay, so we can do this. That is why we are going to return true in this case. Now see this example, frog cool. Frogs are cool. So you guys are going to say that we can insert this SR. Okay, we can insert this part, but these sentences are not similar, since although there is a sentence SR inserted into S1. Okay, we can insert this, but it is not separated from frog by space. Okay, so there should be one exact word. Okay, if it is frogs, then we can insert R, but here it is just frog. I can't add S because S is not a separate word, it is a single word. This frogs is a single word, right? So note that the inserted sentence must be separated from existing words by spaces. Okay, so I hope that you guys are clear with this part. Given two sentences, sentence 1 and sentence 2, return true if sentence 1 and sentence 2 are similar, otherwise return false. Okay, so see this example number 1, my, here it is my. Okay, so this is matching. Okay, and here Haley and this Haley is matching. Okay, this is the extra portion, and we can insert this extra portion here, right? So I'm going to return true in this case. Sentence 2 can be turned to sentence 1 by inserting name is between my and Haley. Okay, see here sentence 1 is off and this sentence 2 is a lot of words. Okay, so here this is one portion that you want to add here, and this is one portion that you want to add here, but in this case our output is false. Why? No single sentence can be inserted inside one of the sentences to make it equal to the other. Okay, so we can't do this. Okay, so we can't insert these two in a separate manner. Okay, so this is one thing. All right, and here see this example number 3, sentence 1 is like this and sentence 2 is like this. So here I can just add this portion here in the end, right? Sentence 2 can be turned to sentence 1 by inserting just single this right now at the end of sentence. Okay, but here no single sentence can be inserted inside one of the sentences to make it equal to the other. Okay, so I hope that you guys are clear with this explanation. Okay, so now let's see how we are going to solve this problem. Okay, so here this is my example number 1. So what I'm going to do here, I'm going to split this sentence into words. Okay, so I'm going to create one string array words 1, okay, and words 2. In words 1 I'm going to split all these sentence 1 words, and in words 2 I'm going to split all these words of sentence 2. Okay, so I'm going to get the words like this now, my one word, then here name is going to be next word. Okay, something like this I will get. Okay, then is I will get, then Haley I will get. Okay, Haley. Okay, so this is how I am going to first split. Okay, then after that I am just going to identify the shorter and longer sentences. So this is shorter, right? This is shorter sentence. Okay, so after identifying this, I am just going to check the common prefix words. Okay, so here this my, okay, so common prefix I am going to find. So this my is going to match with this y. Okay, so I am going to increment, let's say there is one variable I am going to increment the count of I, so I will become 1. Now I move to this Haley, so I am going to check this Haley with this name, so it is not matching. So this is just my prefix count. So one prefix is matching, my is matching with this prefix. Now let's check the suffix. Okay, so I am going to start from the back position. Okay, this position. Okay, so here this Haley and Haley is matching. So let's say I'm counting 6, so J count is match increment to 1. Okay, then I'm going to check this my with this is, so it is not matching. Okay, so it is not matching, so I am stopping here. So here common prefix is 1 and the common suffix word is 1. Okay, so in the end I will just do the count of these two. Okay, so if my I plus J is equal to, or I can say if it is greater than this length. Okay, this length. Okay, let's say this is nothing but my shorter sentence length. Okay, shorter sentence length. Okay, then in that case I'm going to return true. Okay, simply means, okay, if I plus j is greater than this length, simply means here it is 2 now, so here I am getting 2, so 2 is equal to 2, simply means that I have find one prefix and common prefix. Okay, my common prefix and common suffix is matching. Okay, I have found these two words as my common prefix or common suffix somewhere. Okay, so in between I need to add, so I can use that, right? So I can use some other sentence then. Okay, if my prefix and suffix, if my all the words of this sentence too, which is shorter, all the prefix and suffix, okay, is completely matching with the sentence one. Okay, then it is possible. Okay, so here you see this example. So here this is shorter, right? So here this of is neither a prefix or neither a suffix. Okay, so I can't do anything, so I am returning false. Okay, eating here is a, this is shorter. Okay, this is shorter, its length is 1. Okay, now let's calculate the common prefix. Common prefix, okay, 1 is common prefix, so I count is 1. Now find the common suffix. Now is not matching here. Okay, so j is 0 only. So in the end I see I is good 1 and this one both are matching, return true, because I can insert the remaining part then. Okay, so easy, right? Easy. This eating is matching with this eating, that's it, that's it. Okay, so that's what we need to do. Okay, so now let's move to the coding part. So code is very simple for this one, hardly few lines. Okay, so let's write the code. Very simple code for this one, I'm going to say. Okay, so here string of words 1. Okay, I'm just going to split them. Okay, so here sentence 1 dot split, and on the basis of spaces I'm going to split these words. Okay, so I have to write like this. Okay, so here it should be like this. Okay, let's just format it, copy this line, paste it here, and now for words 2, and here I'm going to split my sentence 2. Okay, this is done. Then we have to identify the shorter and the longest sentences. Okay, shorter and longer sentences. Then in that case we need the shorter one, right? So here I'm just going to use this words 1, otherwise I'm going to use words of 2. Okay, that's it. So copy this, paste it here, and now here shorter longer, you can say longer words 1 dot length. If it is greater than my words 2 dot length, then use words 1, otherwise use words 2. Okay, so now this is done. Now we have to find the common prefix. Okay, longest common prefix and suffix. Okay, so create two variables, int I is equal to 0, j is equal to 0, right? And now we have to check common prefix words. So how I'm going to do that? So while my I is less than shorter dot length. Okay, so I'm checking shorter one only, shorter dot length, and my shorter of I. Okay, shorter of I dot, shorter of I dot equals, okay, if it is matching with longer of I. Okay, so I'm just checking the common prefixes, right? So here, if this is the case, increment I, increment I. Okay, now same way we have to check for the longest check common suffix words. Okay, so here I'm just going to write while. So let's take variable j as while when j is less than shorter dot length. Okay, so from shorter only I'm trying to search. Okay, and now we have to check from the end. Okay, so here what I'm going to do, so now understand it carefully. Shorter, shorter. Okay, and inside this shorter, what is the total length of this shorter? First, shorter dot length minus 1 minus minus 1 minus j. Okay, if it is equal to, okay, last word I'm saying, if it is equal to, equals, and inside this I'm going to say longer. Now longer's last word. Okay, so here longer dot length minus 1 minus j, that's it. Okay, so if this is the case, okay, last words are matching, then increment the j value, that's it. Okay, now just single line is pending. Okay, so if the total common words prefix plus suffix cover the entire shorter sentence, we have to return true, right? So here I'm just going to write one more line, return I plus j, okay, is greater than equal to shorter dot length, that's it. Okay, now let's run it and see if there are any code issues, then we try to fix that. So yes, there are some code issues, so let's fix that. Spelling mistake, I think, here LGTH. Okay, so here where is that? Line number 14. Okay, so let's fix this. LENGTH, LENGTH. Okay, let's run it again. So the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? And the time complexity is of n because we are iterating over all the elements one by one, right? So see here, so we are just splitting the our strings, right, sentences strings, and then we are just iterating over we are just calculating our common prefix and common suffix, right? So there may be case when all the both the strings are equally matching. Okay, so then we have to iterate over all the words. Okay, so that's why I'm saying that my time complexity, you can say, is going to be of n. Okay, so I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.